Hey everyone, Lorenzo here. This is a walkthrough weeks 4 problem assignment in the famous Harvard class Introduction to Computer Science, or better known as CS50. The name of this exercise is Recover. And if we go to the exercise instructions page on the CS50 website, we see that the idea here is to recover JPEGs from a raw file that is given. And there are a few details that we need to know in order to solve this exercise. First, when we're talking about JPEGs, they do have a particular header or a signature that tells us that in fact we have a JPEG. How do we know if we have a JPEG? Well, we need to look at the first 4 bytes. The first 3 bytes have to be the exact same values as the one shown here in hexadecimal. And then the 4th byte has to be any of these values shown here, shown again in hexadecimal. And remember that one hexadecimal digit represents 4 bytes. So what we are seeing here is that the E is repeated, and then we have 0, 1, 2 through F. That is telling us that the 4th byte has the following 4 bits in binary notation, 1, 1, 1, 0. The second detail is that we are going to have a raw file that has pictures stored back to back to back, and we're going to be reading in 512 bytes blocks. So those are the 2 details, the header and how we're going to read the memory card. We can now go ahead and think about the pseudocode. And we can formulate the steps that we need to solve this problem. First, we're going to open the memory card. And then we're going to read in 512 bytes blocks and look to see if we have a JPEG or not. If we have a JPEG, then we need to open a new file and write until a new JPEG is found. We can think about schematics here. I'm showing some figures taken from the CS50 website. Here we have we can imagine and pretend that we have the memory card, and we're going to read it in 512 bytes blocks. We're going to start with the first block, and we're going to see, do we have a JPEG? Maybe we don't. So we move on to the second block. Let's check again, do we have a JPEG? No. Let's move on to the third block. Do we have a JPEG? No. Let's move on to the 4th block. And here we see that we have the famous JPEG header. So we know that we have a JPEG. Great. We're going to open a new file, and we're going to write until a new JPEG is found. And that's what we see here. We keep writing, writing, and writing until we find a new JPEG. And we're going to repeat this process until we are done with the memory card that we are given. When we think about the functions or the data types that are going to be involved in this exercise, we see that when we talk about the functions, we're mainly going to use functions within the file input and output category. We're going to use fread, fwrite, fopen, fclose. And we are also going to take advantage of sprintf from the standard IO library. In terms of the data types, we're going to mainly use pointers and also unsigned integers of 1 byte. Now I'm going to show you the code that I'm giving a link in the description below, and we're going to go line by line, and I will be explaining what each of the lines mean for your understanding. This is the solution. You can copy and paste this code and pass the assignment, but that's not the idea. We need to make sure that we are understanding what we are doing. And if we take a deeper look at this code, then we see that we can divide it into 3 categories. we have the first part that deals with the headers and all the user inputs. Then we have a section where we are initializing the variables. And finally, we have the while loop, which is the meat of the program, where we are constantly reading and writing as we go through the memory path. If we dive deeper into the first section, we see that here we have the headers. Basically, these are the libraries we are importing, and this has to do with the compiling. These libraries have the machine code of all the functions that we are using in this program. Then we need to check and make sure that the user has provided a raw file that we're going to read. That's why we see argc, we see the if statement comparing argc to 2. Remember that whenever we are passing arguments into the main function, we are by default passing the name of the program. So if we think about it, we are passing the name of the program 1 and 2 a raw file. So if the user passes something else and the argc variable is greater or less than 2, then we need to make sure that we stop the execution of the program, and also we are printing a message so that the user knows how he or she has to use the function. All right, now moving on to the input file. We are going to open that memory card, and we are going to generate a pointer using fopen. Here we are passing the name. Actually, this is a pointer to the first character in the raw file string. We're going to read that file, and we're going to return a pointer of type 5. This is good practice, standard good practice, making sure that the pointer is not null, but rather a valid address in our memory. If that's not the case, then we're going to throw another error message, and we are going to stop execution. Then we have section number 2, which is, again, initializing variables that we're going to later use in the while. Here we have an array called buffer. This is a chunk of memory of length 512 of type uint 8_t. This is just saying an integer that takes 1 byte. So another way of thinking this is that we have an array that stores 512 bytes. And that has to do, remember, with one of the details instruction that we're going to be reading in blocks of 512 bytes. Here we have a counting variable of -1. We will see later why we need -1 and not 0. Here we have another array or another pointer of length 8 that is going to store the file name. Remember that we are going to be creating JPEG files, and we are going to start from 000 up to all the JPEGs that are discovered as we are reading. And then we have another pointer to a file that we are initializing to null. And this is another good practice. Whenever we are initializing pointers, if we are not going to provide an address at the point of declaring the pointer, then we need to set it to null. And now we can go ahead and focus on the meat of the program again. And for that, I'm going to actually go to the IDE, and we're going to use the debugger to make sure that we understand how this works. Because at the very beginning, I had some issues with that. So let me close here. Here again, we have the instructions, which are very clear. And here we have the CS50 IDE. I'm going to first compile the program. And we're going to look at the debugger. I'm going to set a checkpoint at line 30. Let me fix the screens here. Okay. And we see here that I'm executing the program and that I'm passing the raw file that we are going to read. The program runs until it finds the checkpoint on line 30, and we can see all the variables that we have so far. We see that the argc equals to 2, y2 because we have the name of the file, and 2 we have the raw file. We have count set to -1. There was no error. That's good. And then we see that we have initialized the output pointer to null. We have the input pointer to where the raw file is. That's again an address in hexadecimal. And we can now look into the first 512 byte block. Here, remember the way that fread works. We have an input file where we are reading from. We're going to read one element of size 512 bytes. And this is where we are going to store what we have just read. And again, buffer is this array of 512 bytes. So this could have been larger actually, but it has to be at least 1 times 512. Or in other words, the size times the quantity. Great. So we're going to read the first. We have just read the first 512 bytes block, and now we're going to check this is the condition to check if we in fact have a JPEG or not. Let's see. So we're going to step into, and no, we didn't have a JPEG on those first 512 bytes. Count is still -1, so we're not going to write anything. We're going through the loop again. This is the second block. We're going to check. We don't have a JPEG. We don't write anything. We jump back to the while loop again. We're reading now the third block. We found the JPEG. Now we are setting count to 0. This is just a line to name the file. If you see here, this is just a flag, meaning that we actually want to have leading zeros. We're going to have 3 digits, 3 integers, .gpg, and the integer that we're going to use is count. So this is just saying that the first file will be named 000.jpg. We're going to open that file. We're going to see here that output changes. We see that the address of output changed from null to this address. And then we're going to write, since count is larger or equal to 0, we're going to write all the data that is stored in the memory card. And we just did that. So now we are in the while, we go to the while loop again. And remember that we're going to write if we see here, we're going to write until a new JPEG is found. Remember that we are still in JPEG file 000, and we see that we haven't found a JPEG yet. And you see here that first JPEG file. And here I just want to make sure that we enter the second picture or second image, so we understand how this closed line works. Come on. And here we see that the JPEG files are way larger than a couple of 512 bytes block. Come on, man. Actually, what I'm going to do now is just explain. So again, so far we are in JPEG number, the first image. And the idea here is that sometimes we are going to encounter another JPEG. So now that count is equal to 0. If we find another JPEG, we're going to enter this if statement, and we're going to close that 000.jpg file. This is very important to avoid any segmentation error. We need to make sure that we open and we close the files. So let's picture for a second. Count is equal to 0. We get into this statement. We are going to close that file, and we are now going to set count to 1, and we are going to create another file, this time called 001.jpg. We're going to open, we're going to write, we're going to keep writing until we find another JPEG. If we find another JPEG, then since count is larger than 0, we're going to close that output file, and we are going to add to the count, create a new file, and that's how it's going to load. And if we actually run the program here, so that's a mistake. I need to provide the raw file. Raw, and we see that we have 49 images, and that's what the goal of the exercise was. So now if we talk about the takeaways, first we need to understand the files that we are working with. In this case, we knew we had to read at 512 bytes blocks. That was helpful, and that's needed for any design. Then we need to make sure that we avoid segmentation faults. that is when we are trying to access memory that we shouldn't. That's why I highlighted the importance of setting pointers to null if we don't give them an address right away. And then we need to make sure that our logic is in the correct order. At first, this may sound weird to have closing before we actually open the file, but that's what was needed in order to make sure that we kept writing until we found the next image. So if you didn't understand this part, I would recommend you can copy the code, use the debugger as I did, and make sure that you understand where you are. Maybe a couple of print statements would help. But that was all. Again, this was a walkthrough weeks 4 exercise, recover. Hope you took something out of the video, and see you on the next one.